Hey guys, let's finish up our example from class today using Desmos to fit a regression line to our data. In class, we did example 6, graphing by hand. So let's turn this data in and use Desmos to graph and find the linear regression line. We'll see that it's a lot more accurate of a line. So within Desmos, we can click Start Graphing. And the first thing we're going to do is fill in a table. So to add a table, we go to this Add Item and then Table. And our X values are 0, 1, 2, 3, 4, and 5. Our corresponding Y values are 2.9, 3.1, 3.5. What's great about using Desmos is that it takes all points into consideration, unlike the one we did by hand, took only those 2 points that we did. This will take care of all of them. So then it says to insert the information from the table in Desmos, and we want to add another item. This time we're going to add an expression. So we're going to grab the expression so it opens up a new line down here. And it says to type in the equation y sub 1 is about equal to m times x sub 1 plus b. So down at the bottom, I'm going to pull up my table pieces here. And when I click ABC, down on the bottom here, we have a sub b. So click a sub b. Oops, first I need y, a sub b, so then it gives me a little one. I'm going to arrow to the right, then I'm going to click a little farther over to the right is the little tilde, the about sign. I'm going to type mx, again the a sub b, so I can get my little 1. And then I'm going to add plus b. So notice when I have, and I'm just going to close this here so we can see a little bit more. Why do I need the sub 1 and the sub 1 here? Well, it tells Desmos that I want to use my x values from table 1, so notice that this x sub 1 matches this x sub 1, and this y sub 1 matches this y sub 1. So if we were to have multiple tables or multiple equations all at the same time, it tells Desmos where to look for the data points. And we can see that our linear line is very close to our points here, so it's a good representation. Also, our R value here, notice how close to 1 that is. That tells us that our numbers are correlated very close to a linear line because it's very close to 1, so it's almost dead on. So in our lesson, we can now provide the following information. R squared was 0.9859. And we're going to use that r squared when we work with quadratics. So right now we're just curious about this. And I'm just filling in. What do you suppose our m represents? If you think that it's slope, you are correct. So it gives us the slope, and it gives us the y-intercept that we need to write our equation. So now we can write our equation in y equals mx plus b form. So y is equal to m, which is 0.3143, times x plus our b of 2.8476. Okay, so this is our equation. It says for a more exact, we can add another item into Desmos to see where it intersects with the already drawn regression. Okay, but before we do that part, let's look at what we can do to replace x with so we can answer the question. So just like the previous example, we have 2018 with our year of 8. So if we were to replace our x value here with 8 instead, just like we did the previous page, we can see that y is going to equal approximately $5.4 million per 30-second commercial. Okay. Another way we could do this is looking at Desmos. We said that our x value is equal to 8, so I can say we want x to equal 8. Notice that it drew a vertical line here. I can click now on my point and see where they intersect, and notice it's the exact same answer that we received when we plugged it in. Okay, so we can predict, filling in our last box here, that we can predict that there will be $5.362 million for a 30-second commercial in the year 2018. We can also try to figure out how many there would be, let's say, in 2020. So our x value would be 10. So in the year 2020, we could expect a 30-second commercial to be approximately $5.9 million. Okay, so by having this, we can predict a lot of future within the equation and linear expression. So I hope you find this useful, and please use this when you're working on your homework for this lesson.